Record. Hello and welcome back to Chemical Engineering Part 4, questions 80 through 100. I should probably give an apology before I start. This video is 6 months overdue, probably 7 by the time you guys see it, but it was a lot going through. Back in October 9th, when it was the last upload for Part 3, I was going through a job transition, and the job I was working at the time, what had happened was that it became a little bit too much. I was already getting overworked as is, walking 10 to 20,000 steps a day, depending on what the heck I was told to do. I had to transfer all the prior knowledge I had on the scale up work to the team. And safe to say, all of that bogged me down. The official change of jobs came in like the end of November, start of December. And during that transition period, I wasn't sure if I wanted to continue, doing the FE exam myself. So half of it, the motivation wasn't there. And during that transition process, I wasn't sure if I was going to get anywhere, to be honest. So November and October, I pretty much screwed myself just with transition and leaving all my prior work to the last job. December was acclimating to the new environment. January was still acclimation. February, I realized that I was going to have a little bit more time here, but I still hadn't had a real reason to do it since I wasn't sure I was going to take this exam myself. And I got kind of lazy, I'll be 100% honest. But then in March, I read a couple nice comments from the people in the last couple of videos, especially in part 1, saying that these have been extremely helpful for them. And it sort of like motivated me a little bit to at least finish the series if I don't even end up taking this exam myself, because I work in R&D and I don't think I'll ever need to be a professional engineer myself, but I can still share my intelligence since I was a smart kid in college. And I don't mean to flex or nothing, but I did graduate a 4.0 in chemical engineering. So there's a reason these videos are well structured. All of that being said, you might be seeing that there is no video of my face, right? It's because I'm using my desktop, and so that might explain why the microphone sounds really awkward too. But I might have to record this if it doesn't sound good, but I'm hoping it works. I'm on my desktop. There's no front camera, but it gives us more space to write and do stuff, so that's how we're going to do it. With that little preamble out of the way, I'm going to get to what you guys were here for. And I even have everything, the setup's all working. It might be a little awkward just because I haven't done this in a while, but we'll try to do this. Okay, so 80, it says a control estimate was developed for a project on 30% level to project definition. Okay, a control estimate was developed for a project on a 30% level of project definition to increase the project definition to produce an estimate check. A minimum level project definition needed is most nearly. Okay, so as a lot of you might be questioning, what the hell did I just read? When I first read this literally yesterday, I had no idea either. So basically the key word for this is that the key words here for this specific question are this right here: project definition. If you don't know what a project definition is, it's basically the key to this entire question, because this question is essentially saying, what is the minimum level of this project definition to give to be able to estimate a check, basically. So I did something cool here, so I don't have to keep going through the FE handbook. I went to the FE handbook and decided to screenshot important things we're going to go through. So you go in the FE handbook and you go under the economic section, and you'll go under classification of cost estimates, and you'll end up finding this table that says level of project definition as percent of complete definition. Now, remember, the question is asking us, we want to produce a check. So we go under, we'll look for what we have a typical purpose and estimate. There's class 5 all the way to class 1, and the project level definition, where it has the minimum and maximum percent, where you can supposedly get whatever these guys are as an estimate. So again, the question says, what is the minimum project level definition for a check estimate? So you go here, class 5 says screening or feasibility. Well, no. Concept study or feasibility? No. Budget, authorization, or control or bid tender. None of these above mention check estimates. So do we care? No. Check estimate or bid tender, class 1. Okay, next part of the question: level of project definition as complete definition. Well, shit, look at that. 50% to 100%. And it's asking for the minimum level of project definition, which you can clearly see is 50%. Now, going back to our said question here, we're going to be looking for, annotate. Ooh, I'm a little sticky. It'll be C. And we went through the process as to why it would be C. So anytime you get into the economic section, you just should bust out the economic section of the FE packet. I'm not sure how it works on the exam if you can control F, but granted, I controlled F and I found that table relatively quickly. 81. A company can manufacture tools using hand tool. A company can manufacture a product using hand tools. Tools will cost $1,000 and the manufacturing per unit will be $150. Remember, boys and girls, what did we say in all my videos on how to do this? Basically, if you give me 1 second, I need to get my actual answer to this. Give me 1 second. Okay, sorry about that, guys. Basically, my dumbass doesn't have that one written in my notes, but I can explain it through the through the answer key. So, okay, a company can manufacture product tools using hand tools. The tools will cost $1,000, and the manufacturing per unit will be $150. And as an alternative, an automatic system will cost $1,500, and the manufacturing per unit is 50 cents. The annual volume of units is supposedly 5,000 units, and we're going to collect interest, and we're looking for the payback period mostly. Payback period basically means if I decide to go with the super expensive shit, how long is it going to take for me to basically get my money back if I were going with the shittier unit? So I'm going to go use the only question I'm going to do this for. Basically, remember, for the more expensive option, it was $150 per unit. And total, it's $1.50 per every unit we make. So we have a total of 5,000 units we're making per year. 5,000 units per year multiplied by 150 per year. You'll get a total of $7,500, which you immediately are spending to make those. On the flip side, if I do 50 cents per unit and I'm totaling $50,000 per year, 50,000 units per year, 50 cents multiplied by 5,000 gives you $2,500 per every unit you made. So these are the two numbers that you end up getting. So in essence, how do you decide which one is cheaper? Well, you take the difference. So you'll get your 7,500 and your 2,500, and you'll get a total annual savings of $5,000. But that's not the whole story necessarily, because you have to remember, you are originally also investing in the beginning. So when you're investing, you are not just getting away with $1,000 and your manufacturing being $150. You're not getting away with only doing 50 cents per cost a unit if you have this most expensive machine. You have to remember your initial investment, because that matters. So your initial investment for tools will only be $1,000, and your initial investment when you're talking the super expensive $15,000 machine is $15,000. In essence, just looking at the total numbers for the tool versus the machine, the tooling obviously being cheaper, the super expensive machine obviously being 50 cents versus the tooling being $1.50. Straight off the bat, you can see overall your investment is going to be cheaper, but you don't know that for sure. So you're going to do the difference between your initial investment, which is your 15,000 for your super expensive machine, minus the initial investment in the hand tools you're going to use. So in essence, you essentially would be still investing $14,000 if you're going to go with the more expensive route. Now, the question is, how long is it going to take you to get your money back if you were going to invest in this $15,000 route instead of the cheap $1,000 route? So you'll take your $14,000, which is what you're actually going to be putting into this system if you decide to forego it, and then you divide it by your supposed savings if you go with the more expensive route, which is going to give you 2.8 years. Now, again, I want to apologize. That is the only one we're going to use that disgusting handbook for. I genuinely don't know why I didn't have this one written down, which was a mistake. As for 82, piping instrumentation, P&ID, would not contain which of the following: installation specification, process steam, compositions, fail close, fail opens, indications for valves, locations for safety interlocks. Now, this is another one we're going to go to our little guy right here. This isn't necessarily in the FE handbook, but I thought it was very important to answer this question. It says here, functions and purposes of P&IDs. P&IDs are foundational to the maintenance and modification of processes that it graphically represents. At the design state, the diagram also provides a basis for design development control schemes like HAZOP, Hazard Operational Safety Study. For processing facilities, it is a graphical representation of key piping and instrumentation details, control and shutdown schemes, safety regulation requirements, basic startup, and operational information. Now, with all that being said, let's go back to the question. So remember, safety is basically number one. Fail, close, fail indications for valves. That's safety. Immediately it's going to be on there. Locations of interlocks. Immediately is going to be on there. Installation specification identification. Installation specification identification. Say that 5 times faster. Now that is specifying installation on your pipes, which is key piping and instrumentation details. Key piping and instrumentation details. So A can't be it. So what is not going to be on there? Well, based on the logic we just went through and what P&ID should be sharing here, P&ID should be sharing. I'm sorry about that. The logic here, your answer is going to be B, steam compositions. P&IDs don't share that. They don't need to. They don't specify that. So there you go. As long as you know what a P&ID is, that should be easy points. 83, which of the following situations is appropriate for using break-even analysis? Where we talk about break-even analysis, let's talk about what break-even analysis means. It is also in the FE handbook. I'm pretty sure I have it in here. If not, I have it written in my notes. I don't have it in here. So, I have it here in my notes. Break-even analysis is assuming that one variable in a situation is held. One variable in situation is changing while the rest is held constant. This implies you know every value in this situation except the one is changing. So with all that said, the break-even analysis is basically, let's think about how long it takes for me to get my investment back. If I'm going to break even, it literally is what it means. Breaking even is legitimately just making your money back. And that's it. That is a break-even analysis. It is the study of buying something, determining if I change one thing out of all the variables, how is that going to affect me breaking even? It doesn't tell you anything else. So it says A, calculating interest rate will ensure costs and returns are equal. Well, again, we're not talking about interest rates because all we care about is breaking even. So that's out of the window. C, establishing the minimum return on investment for over a set of years. Well, minimum return of investment, or ROI, if you're in process development class, part 1 or 2. This is what you talk about. You go through your cost analysis. ROI basically tells you if it's safe to buy this system, if it's a smart investment to do. It's not necessarily breaking even, so no. D, forecasting the amount of product that must be produced to set a profit margin. Also false, because again, break-even analysis literally is what it means. How much does it take for me to break even? You're not talking about making profit. If you can even make profit, that's out of the window. How about B, determining number of units to produce to ensure income covers expenses? Well, that pretty much is what break-even means, right? We're trying to cover our ass. We need to make sure we make even. And how do we do that? We sell enough units in order to become level. We're not going to make a profit, but we'll be level. And that's what a break-even analysis is. Okay. So 84, I like 84 actually. 84 is pretty fun. Using the pump curve shown below, you will specify a pump to deliver 22 meters cubed per hour at the head of 15 meters. With a head of 15 meters, basically. Match the impeller diameter, the pump horsepower, and the pump efficiency with the most appropriate measures. Now, you might be like me, and you might honestly be thinking, what the fuck is this graph here below? With all of that being said, this graph is actually not hard. Let me get my annotation tools out, and I'm gonna, I love the straight line feature here. It's been a while since I used it. Okay, so basically what this guy is a capacity versus total dynamic head. And if you guys can see, I'm going to turn back into my squiggly line so we can talk. The efficiency lines are marked by these guys here. That's 60, that's 70. This 72 right here. This 70 and this 60. Those are all efficiency lines. Since you can see the efficiency right here. Now, these these straight lines you see here and here are kind of like a barrier. In between those lines, you'll basically get a barrier of what your diameter size is. So between here and here, your diameter is going to be 6 3/4, and etc. Here's going to be 7 3/4, and here's going to be 8/16. This is going to be 5 3/4 in between those lines. What else does this thing tell us? It also tells us horsepower. You see this line here? It matches directly with this horsepower line. This line here, horsepower line. Again, here and here. Some of these lines aren't straight, as is, but it is what it is. But you can tell those are horsepower lines. Okay. Now on the side, it gives you this. This is a nice little graph here. We're talking both SI and American Engineering Tools. Feet here for the guys who want to make spaceships crash, and meters here for everybody else in the whole world. Now capacity, we have gallons per minute and then meters cubed per hour. Again, we have to work with what we're given. So here we have 22 meters cubed per hour at the head of your pump. So you see your capacity. Here's your meter cube per hour. This is about 20. So I'm just using these lines as a little estimate. This is going to be 21, 22. It'll probably be right around here for about 22. Now, how about 15? You need a pump dynamic head, and it says a head of 15. 15 is here. So we're just playing the game of a straight line. Straight line connected to straight line. And actually worked out pretty well. Straight line with straight line, big old dot. Obviously, this is a little too neat. I would need to bring this down a little bit to like match there, but you're just guesstimating. So what are we having here? Let's change the color. So first and foremost, we're in this 72 line. And this 72 line, as we discussed previously, is talking efficiency. So immediately we know the pump efficiency is going to be matched with 72%, which is awesome. Now, the next thing we're asked is this impeller diameter, which should be 7 3/4, which would be right about here. Again, it really hard. Let me change that. That looks nasty. That 7 3/4 is the hardest one to tell if you draw these lines a little iffy. And since I'm drawing it on a computer, they might be a little nasty or hard to tell. Let me make it purple. But if I had this line a little bit more down, it would be right around here is where the dot would actually be. So you'd be in the 7 3/4 range right here. Again, I drew this a little too neat or a little too off. This stuff matters. It's hard. You have to eyeball it a little bit. But in between, it'd be 7 3/4. Again, on my hand work, it doesn't look this this ugly. And I'll show it to you guys in a second. Now, that impeller diameter is going to be that 7 3/4, which is awesome. How about your pump horsepower? Again, your pump horsepower, this dot is right about on this line right here, which is 2. So your pump horsepower is 2. You just have to eyeball it, but for the most part, if you were to draw this incorrectly, you'd still get 2 out of 3. You would be on the correct horsepower line or close enough to 2 to guess it. You're in still the range of the 72 pump efficiency because it's in the box. The only one you'll have to be guesstimating is this A, B, or C, or D, A or B diameters. Again, it just depends on how you draw it. And you'll see right now that on my paper, my physical paper here, it looks a little bit better. Oop, I didn't include it in my notes. It's okay. But on my physical paper, these lines look a little bit shittier. And so they'll be on the bottom part, more on the B than the A. That's where they should be. But overall, these lines are fine. That said, that's how you answer that question. Not too hard. Annotate. What are you doing, sir? Play, exit. 85. So let me flip my page here. I like 85. Now this is where we get to like what I'm actually really good at explaining, and that's just math. So a recent purchased shell and tube floating head carbon steel heat exchanger containing 400 feet squared of surface area. Cost $8,700. The estimated purchase of a similar heat exchanger costing 200 feet squared of surface area is most nearly blank. Okay, so don't make the mistake I did when I first answered this question. I was like, well, it's half the surface area, so the price should be half. My dumbass said it should be 8, but it's not. Don't do that. So what you're actually going to do is you're going to go to your FE handbook. You're going to get a couple things. In your FE handbook, you're going to go and you're going to find under the economics section, engineering economics, scaling of equipment cost. And this time I made up for my my bad handwriting. So scaling of equipment. The cost of unit A at one capacity related to the cost of a similar unit B with X times the capacity of unit A. In this case, we're talking surface area as approximately X times the cost of B. So they give you the equation, which is cost of unit A is equal to cost of unit B multiplied by the capacity unit of A. So basically your surface area divided by the surface area B to the power of N. Now, what are the exponents for N? In our case, it's talking equipment, the size, and then it'll give you an exponent. So again, the question says it's shell and tube heat exchangers. None of these matter except for heat exchanger here or heat exchanger here. Now the question is, what type of is it? Is it a floating head? Is it a fixed head? What type of material? Carbon steel, pure steel, etc. Luckily for you, the question says it's carbon steel and it's floating head. So you immediately know you're going to have to use this. But on the page, it also gives you a size range, which can be vary from 100 to 400 feet squared. We're using 200 squared and a 400 feet squared heat exchanger to compare. So you know you're okay using this exponent of 0.6. So now, let me go back to mouse mode. And let's start going back here to draw mode. Okay, so the basic equation was, I'm going to just say unit A is equal to unit B multiplied by the surface area A versus surface area B to the power of N. And in this case, we want to match everything. I say unit A is what is given. So what is given is 8,700. We are looking for the cost of unit B, so that's X. And we're going to simply multiply it by the surface area of unit A, which is 400, divided by the surface area of unit B, which is 200, to the power of 0.6. It's a little ugly, sorry guys. When you solve for this, you'll end up getting X is equal to $57.40. So $5,740, which would be B. Simple, very simple. You just, if you guys get the gist of it, most of the questions on this exam are just plug and chug, and that's like a pure example of plug and chug. Okay, 86. 86 is the standard, the recognized standard for pump for pressure vessel design is published and maintained by which organization? Okay, so we're basically asking the question, who is regulating pressure in the vessels? That's the question. It says American Society of Mechanical Engineers. Well, I just want you to know that there's an American Chemical Association, there's an American Chemical Society of Chemical Engineers, there's an American Society of a bunch of engineers. They don't really do shit in terms of regulating much. They sort of just publish journals, I believe. Someone in comments will probably comment that. But when I read American Society of Chemical Engineers, it makes me think of the ACS or the American Society of Chemists. Or no, the ACC, the American Chemical Association, the American Chemical, AJAX, they publish papers basically. And they don't really do much else. B says the Institute of Electronic Engineers. Well, for starters, it's electronics, so I wouldn't directly think pressure when I read that. And B, they give good advice for electronics, which makes sense, but that's about it. They don't really do too much else aside from that. EPA, the Environment Protection Agency. Well, does pressure vessel design protect the environment? No, and it's just protecting the environment. The National Fire Protection Association. This is the correct answer, and although the name suggests they just talk about fire, since you would think firefighters, You also have to remember that firefighters need the correct pressure on their items in order to get their hoses to go, right? That's sort of the logic I like to use in order to match them. Fire hydrants need the correct pressure on their vessel, so if there's an emergency, they can actually put out the fire. And that's just one example. The National Fire Protection Association, they also have codes to limit this stuff. They're the key safety measurements. 9 times out of 10, if you guess National Fire Protection Association, it'll be good. But in this case, just think firefighters. Firefighters think fire hydrants. Fire hydrants need pressure, and so pressure vessel goes with D. So the answer in this one would be D. I don't need to circle it. We'll go into the next one. A lot of these first couple aren't a lot of math, which kind of makes me sad. So you won't hear me ramble on for too long. Okay. So 87 says the following table is a summation of manufacturing and product sales profits from a 5-year period. So basically, this is a 5-year period, and it gives us manufacturing product sales from all these 5 years. The graph shows the percent sales profit per unit, the manufacturing cost per unit, the pounds of waste generated per unit, and it says then to select the table that shows where, select the section on the table that shows where the plant's profitability is maximized. So just looking at the table, we can tell a lot, actually. So here in B, it is the manufacturing cost, so dollar per unit. Every unit costs this much to make. So in B, we see there's $28 per unit, and it progressively gets worse to 38 and 50, and even 65, I assume it's circled there. Sales profit per unit. Sales profit might be the like a little red herring to want to pick it, because obviously if your sales profit per unit is high, you would think this would be the correct answer, but it's not, and we'll get to it in a second. And then the reason this one down here is just the price per unit, and you would think the manufacturing cost wants to be low in order to maximize a profit. So this isn't necessarily true either. So over here, but you don't want to be too low and you don't want to be too high. You just don't want it to be screwed. Waste generated pound per unit. So this is just a general number of waste. Ideally, you don't want to be wasting too much, but if you have to, then you have to. But you also have to come in mind that the more items you make, the more waste you're going to have. So in general, it kind of scales evenly, even though you'll notice down here where it's at 400, you'll have 62 versus up here at 100 where it's 32. In general, the more you make, the more waste you have. So this is kind of a no-brainer. Why not to pick it? It doesn't really tell you much, because if you make more, you'll have more waste. Now let's talk about A, the overall profit per day. Now A gets tricky because the question is asking where is the plant's profitability maximized? And essentially, we want to make a profit. The highest profit we make per day is ideally what we want. So basically, look at this table. You have 72, 11, 14, 17, 20, 22, 23, 22, 18, 12, and 72. And these are all based on the same units per day. Basically, you don't want to live down here where you're making 600 units per day and only profiting $72 or $7,200. That's shit. You don't want to live up here either, because you're only making 100 and you're profiting very little. I'd rather live up here, though, because you're only making little and profiting little versus making a shit ton and profiting very little and making a lot of waste. Now, look more ideally in the center. Here you're making 300 units to 400 units. You're making a decent amount of waste, but it's not too bad considering you're making a lot of them. And the manufacturing cost per unit is relatively stable. It's not the lowest it can be, but it's not 50 either. Also being said, notice how 20 Gs, 22 Gs, 23 Gs are the highest numbers here. This table basically says, how much money did you make that freaking day? And obviously, 23 Gs, 22 Gs, and 20 Gs are the highest numbers here. They don't represent everything else we talked about. So the only logical answer here would be A. So that would be that one. Now you might be asking, what's this graph about? This graph is just to confuse you. I mean, it shows you the waste generated per unit, the sales profit per unit, the manufacturing cost per unit. But guess what it doesn't show you? The actual answer, the overall profit per day. But what's kind of cool is that if you look at it from 300 to 400, that's kind of the range you want to look. So here's your 300. Here's your 400. Like, look at your the squares, the sale profit per unit. They're not necessarily the best. Look at the circle, which is the manufacturing cost per unit. They're not the highest and they're not the lowest, but they're right there in the middle. The waste generation per unit, which makes sense. It trends upward with more stuff you're making, but it's not the worst it could be. But ironically, what this graph doesn't tell you is how much money you're making in these periods, because I guarantee the money here would trend very differently. As you see, your money graph, if you follow what this says, at 100, it'll go high to like 72, and it reaches its peak over here at 23, and then it dips down. So clearly, you're maximizing your profits here if you put it all together. Okay, 88. I like 88. 88's a really fun one. I actually had a little bit of fun. I even made an Excel sheet for you guys. I know you're not allowed to use an Excel sheet, but I just think doing the same calculation 15 times is annoying. On the exam, you'd have to do the same calculation 15 times, but it's not that annoying. Okay. You must choose between 4 pieces of comparable equipment based on the cash flows given below. All 4 pieces have a life of 8 years. So there's a lot to read there, but we'll get back to it. Then they show you a graph. It has the first cost, the annual cost, salvage value, how much the equipment costs, A, B, C, D, and E. Discount rate is 12%. Ignore your tax. And then it says select the 2 pieces that are most preferable, the ones you want to buy. And the difference between their present worth values are most nearly blank. Well, there's a couple things you need to realize. That last sentence here is like the most important thing. And the reason it's the most important is this part right here. The present value worth are most nearly. The reason that's important is because we have 4 pieces of equipment and they all have a lifespan of 8 years. And certain aspects of these things aren't going to really be talked about in present day. Like salvage value, for example. You don't salvage something until you're done with it. In that case, it would be 8 years later. Annual costs are affected every year, and they need to be. So the annual costs for year 1, year 2, year 3, year 4, they all need to be combined and turned into a present day value. And you might be wondering, how the hell do I do that? But they give you all the information. So they tell you the years, they tell you the cost of everything. They give you an interest rate or a discount rate, which are essentially the same thing, basically a percentage. And they give you a lot of things to work with. So just with those 3 things, it should give you something to like think about. And since I know 90% of you have been to chemical engineering school, where's my you should also have something ringing in your heads, which would be costing. And how do you cost something according to chemical engineers? Well, according to chemical engineers, costing can be done with this chart down here. This chart's found in the Chemical Engineering Handbook 2. It gives you a certain numbers of things that you can work with. For example, here we have a single payment, which would be our salvage value that we want to bring to the present. And then we have a uniform series of payments, which would be our annual payments to like maintenance or whatever the heck it was. I'm not sure if it says maintenance. We'll make sure. Our annual costs, which you could call them maintenance. I call them maintenance. Your maintenance cost every year for your piece of equipment costs money, but they are a series of costs. So we need to bring all those series of costs to the present. Now, how do we do that? Luckily for you, I'll guide you. So the single payment that we have to idealize to the present would be a single payment. And we want P given F. So this is the first thing you want to look at. And you might be wondering why we picked that. And the simple answer is that we're given the cost of the future. Our salvage value is 8 years in advance. That is not the present. That is the future 8 years from today. We do not give a shit about its cost 8 years from today. We care about its cost like now, the present, because the question is saying we need to presentialize it and bring it to today versus tomorrow. In order to do that, we need the single payment present worth. It'll take it back in time for us to cost it as if it were today. So P, we're getting P given the F value. F being future, P being present, I being the interest rate / or discount rate, N being the number of years. I'm going to give you the formula: 1 plus I to the negative N. How about the annual maintenance cost or the annual costs? Well, again, that's a uniform series works of payments. It's not just one payment, it's a series of payments throughout the given number of years. And it's the same idea here. We need P as in the present. A is that uniform number of payments. It's not one payment. A represents all the payments for all those years, which is in this case would just be A, whatever the number says in those guys. But that's the number you got to bring back to the present, and you have to cost it for every single freaking year. And that's what this equation down here does. So these two will bring with us. Now, how about the rest of these? And, excuse me, before we get to that, uniform series, here's the official term and definition. The terms in the brackets are called the uniform series present worth value factor, or P divided by A factor. This equation will give the present worth of an equivalent uniform annual series A that begins at year one and extends for n number of years at interest rate I. Basically, this here is saying our uniform annual series, which is in this case our maintenance cost, it begins at the first year because once you buy your machine at same year, you have to give it maintenance and that'll fuck up. And it extends for a number of years, in this case 8, with an interest rate that's fixed, which is 12%. In our case, it's a discount rate. So bringing all that together, how about the rest of these guys? Well, the rest of these guys help. As long as you know how to read this, like F, that's future. So you get to the future given a present value. If, say, we wanted to take our current value of the item we bought and brought it to the present. And so on and so forth. Here's the fixed annual payments. We're given the annual payments, but we want to see what it is in the future versus what it is today, which is kind of cool. And the rest of these are also pretty useful, like G. G is in the book and it tells you how to use it. You'll probably never touch that though. I haven't seen the question, gradient, but it's always good to go in there. And if you don't know what to do, the equations there and the FE handbook tells you what all those terms mean. But for our cases, the other two most important. Let me get my mouse back. And I'll take wait, my mouse. Can you tell I'm rusty? With all that said, we want to take this to, I'm going to take it to OneNote. And the reason I'm taking it to OneNote is because we're going to do a lot of math. So let me take a screenshot. And we have OneNote anyways. And the nice part about using a big screen is that I can do this way easier than it was before. Now let me exit that. Let's get it nice and thick. Maybe not that thick. Let me go here. How about this? That's way better. Okay. Okay. So remember what we just said. We have the single payment interest, which is 1 plus I, the power of negative n. And this represents your salvage value, which is the end of life, the money you're going to get back. In our case, 1 plus I, which is 12%, the power of negative 8 equals 0.403. Okay, how about this annualized cost that we need to bring to the present after 8 years? So your annualized cost is that disgusting, really nasty equation that was 1 plus I, the power of n minus 1, divided by I, 1 plus I to the power of n. You just plug and chug, same idea, 1 plus 12%, to the power of 8 minus 1, 12%, plus 1 plus 12%, power of 8. You plug that into your calculator, you're going to get 4.67. Okay, so the things that matter here are your 0.03 and your 4.67. Basically, these are factors that are going to bring these guys to the present. Now, mind you, you might be asking me, what about our first cost? Well, remember, your first cost is happening today. So you don't need to get a factor, or you don't need to use I, you don't need to use N to bring it to the present. It already exists in modern day. So I don't care about it. Now, the next part of it, and we'll do one of them by hand, and the rest I'll just show you how I did it in Excel, says, what is the present value of all these items? So let's do A. So the present value of A, P of A, is going to be equal to 25 grand. Its present value at the time you bought it, plus the annual cost, which is 8 G's. That's multiplied by the annual cost factor, which is 4.67, plus, or excuse me, I almost screwed this up. So 25 G's is you're initially investing in this machine. You are having to invest 8 G's every year in order to keep that machine running. But at the end of life, you get money back. So let's get that as a discount to yourself. Don't add it together. It's your personal discount. That is what you get after taking care of this machine, which is only $2,500 multiplied by your factor of 0.043, which is even less money. So remember, you are investing 25 G's. You are investing this much to take care of it. That's why those two are being added together, while you are subtracting what you're going to get back at the end of life. Basically, your discount, what you get back, your kickback. So it subtracts it. So when you do that, you get a total of 63731.41. And that's in dollars. That is your present day value of just A. So essentially, since the factor for your salvage and your annual don't change, those numbers are fixed, you do the same thing for B, C, and D. And then we'll go to Excel to show you, because I did this at work and I was bored. So I did it. So here in Excel, we have I, which is our discount rate of 12. We have N, which is our years. The uniform series and the uniform single payment, which are the same equations if you guys look. Exact same thing that I just did on paper. See? We just did it easier. The first cost, your annual cost, your salvage value, all the same. Just to prove it, 25 grand plus your 8 multiplied by, your 8 multiplied by your 4.67, and then your salvage value multiplied by your 0.043, which is a really, really, really small number. And you get 63,000. So you did it for all A, B, C, D. On the exam, you did this all by hand, which sucks, but here you did it through Excel. So you get 6373, 63,392, 63,900, 63,222. Out of those options, what are the most cheap ones? Very clearly, it's going to be the 63,392 and the 63,222. Those are your best options. So B and D are your best answer. Now, the second part of this question says, what is the price difference between the two best costs in present day? So obviously take the difference of 63,392 and 63,222, and you get 169.58. Since we're in the real world of engineering, you round that shit up to 170. And you go back to your question. And your answer is going to be B and D at 170. Wonderful. Now 89 is going to be a freaking doozy. I like 89, but it also has a couple things wrong with it, which I don't like. Let me take a sip of water. 89, I'm just going to take a screenshot of it. And we're going to go back to OneNote, because it's going to make my life easy. Oh, yeah, we're getting some space here, guys. We're going to need it. Okay, so 89 says, here's a feedback controller, and it's represented by the following figure, which if you can come here, it is a feedback controller. You can literally see it coming back with this line here. So you see this, there's your transfer function, G of P, your input, which is R, your output, which is C, and then there's this block here, KC. It says, which of the statements correctly describes stability of a system? Now we're going to get kind of crazy, and I want to talk about stability in the process control sense. So you can describe the stability of a controller like this blockchain by the characteristic equation. Stability. Stability is described by the characteristic equation. And that characteristic equation is 1 plus GOL. So 1 plus transfer function open loop equals 0. Or I like to call it 1 plus what it actually is, which is G of P, G of V, G of C, and GM. Essentially, all of these would be this guy and all the other blocks, if it were to have one, equal to 0. And then this is how you find stability of a characteristic equation. You need to be able to take all the pieces of the transfer function of your process control blocks, multiply them together, add it to 1, and equal it to 0. The reason I say that is because we have to recall that this characteristic equation is going to tell us every single thing we need to know about stability. And we'll get to what the keys of stability are as we work through the problem. So let's start. In our case, we have, to put simply, 1 plus G of P, which is 0.1 divided by S plus 1, 2S plus 1. Now, here's something funky that we're going to put here. And don't be scared. Most books don't put the KC here. But G of P, G of V, G of C, G of M are all going to be multiplied by KFC. In this case, this KFC here. But you always do it that way. They just never show it in the books. I won't show it to confuse you guys if you see it in books. But that's KFC. They all end up being multiplied by KC regardless. So this is just the beginning of getting the stability. Now, with a couple of simple algebra, you combine 1 plus this. Remember, 1 needs to have the same denominator as this disgusting mess in order to combine. So multiply 1, pop in both bottoms by S plus 1, 2S plus 1, divided by S plus 1, 2S plus 1, added to 0.1 KC divided by S plus 1, 2S plus 1, all equal to 0. Now combine everything. So the bottom is really nice because these two just add up together. The top, I'm going to do something nice and skip a step. I think you guys are, I won't skip this step. You know what? I'm going to take it one step at a time. So let's combine the bottoms. Some people just need to see the whole thing. And you know what? I can't be biased because I think this is obvious. Although I'm an asshole, so I would skip this step. But I love you guys, right? Okay, so this bottom, S plus 1, 2S plus 1 squared. We combined it because we added them. The denominators are the same. Get this. I'm going to change the red real quick. Multiply S plus 1, 2S plus 1 from the denominator to the other side. So it cancels itself here. And itself multiplied by S plus 1, 2S plus 1. Turns to 0 because 0 times anything is 0. So all we did here was multiply 2S plus 1, 2S plus 1 to both sides of the equation, math legal, and it cancels itself out. So then we're going to be left with the top by itself, which is S plus 1, 2S plus 1, plus 0.1 KC equals 0. Now we're going to factor, or not factor, the opposite of factor, expand these two equations. These guys right here. These guys end up becoming 2S squared plus 1S plus 2S plus 1 plus 0.1 KC equals 0. Combine like terms, we get S squared plus 3S plus 1 plus 0.1 KC equals 0. Now, this is what we actually are going to work with. All of that work, this is your characteristic equation. This is going to tell you literally everything about stability. So all of this work we did above was just to get that. So I'm going to do myself a favor, and I'm going to copy and paste that to the next step. The nice part is that the reason I'm using my desktop, guys, is because I can do this. Or at least I thought I could. We're going to try that one more time before I just rewrite it. Oh, I got it. Proceed. So we're going to step to the next page just because it makes my life easier. Okay. And this is equal to 0. This is that characteristic equation, all that work we did. This is what's going to give us stability. We're not done yet. So stability of the characteristic equation is described by this. So 1, there's 2 rules to it. 1, all coefficients of this characteristic equation must be positive in order to be stable. So in this case, we have 2, 3, 1, 0.1. We're good. Those coefficients are straight. They're not going to screw us over. But if you had -2, it's already non-stable and you finish the question. Here's an issue. Life isn't easy. This exam isn't easy. KC will depend on how to make this thing coefficiently all stable. See how KC is an unknown here? We don't know. KC at certain values might make this equation have a negative coefficient, or KC at certain values might make this equation have a positive coefficient. We don't know. We need to find that answer. And then we can say it is stable at every single place greater than a number or less than a number, or in between 2 sets of numbers. Now, the thing, how do we do that? We need to, 1, realize that 1 plus 0.1 Kc equals 0. Solve for that. We get Kc, it shouldn't be equal to 0. It should be greater than 0 because we don't want it to be less than 0. If not, that means it's unstable. So 1 plus 0.1 Kc needs to be greater than 0. Solve for Kc. You get -10. Kc must be greater than -10. In this case, that's cool, but we're not done because life isn't easy. So at this point, we already said all the coefficients have to be stable. They need to be greater than 0, 2, 3, and Kc is going to have to be greater than -10 in order to match that. Now, the second thing we need to do to make sure our system is 100% stable is do a Routh array. And that's from your process control class. A Routh array essentially is a matrix that is defined of this characteristic equation. And the terms go an plus 1, an plus 2, an plus 3, or an minus 2, an minus 3, and I put plus, it's the same thing. You'll see in the books as plus, minus. In my brain, it makes sense as plus because you're adding coefficients. It should technically be negative. Then you'll have B1, B2, B3, C1, C2, etc. So in the Routh array, an is your highest power coefficient. So in this case, our highest power is 2. So what the highest power coefficient is 2. So here would be 2. On the bottom, it is an, it should be -1, but I put plus. An minus 1 would be -1 because the coefficient would be s to the power of 1. In this case, what will go here would be coefficient in front of that, which would be 3. An minus 2, which would be the coefficient less than s to the power of 1, which would be 0, or s to the power of 0, which is nothing, which would be this term right here. And et cetera, et cetera. If there's no terms to be full in those areas, or if you don't have a coefficient, or if you don't have s to the power of 3, it's just 0, or if you don't have anything less than that, it's just 0, 0, 0. We'll fill it out as is. So in our case, we're going to fill it out. So we have 2, we have 3, we have 1 plus 0.1 Kc, 0, 0, 0, since there's nothing after those terms. Now, that being said, we still need to worry about this B2, this B3, and this C1 term. Okay, so B1 is equal to crisscross applesauce. And what I mean by that is an minus 1, which would just be this. I just put a plus. Multiply an minus 2. So as you can see, these two are just multiplying. Subtracted by an multiplied by an plus minus 3. Should be a minus. Officially, it's a minus. That's this. So crisscross applesauce, all divided by an minus 1. B2 is the same idea, except we crisscross applesauce a little bit different. It'll be an minus 1 multiplied by an minus 4 minus an crisscross applesaucing with an minus 5. Again, this should be minus. All divided by an minus 1. How about the C's? C's are similar. C1 is equal to B1 multiplied by an minus 3 minus an minus 1. An minus 1 multiplied by B2. All divided by B1. And in the same sense, C2 is equal to B1 crisscross applesauce with an minus 5 minus an minus 1 multiplied by B3 divided by B1. Now you might be wondering, why the hell are we even doing this? I want to clarify that the characteristic equation having positive numbers in the coefficients isn't enough for a stable system. The Routh array, everything in the first row here, or the first column, everything in the first column here must be positive in order, must be a positive number in order to be stable. So we need to fill everything out basically to make sure our Routh array is okay with this system. It must be greater or equal, or a positive number or equal to 0 in order to be stable in association with these terms being greater or equal to 0. This whole row has to be it. That's the reason we're doing it. So we need to find B1 in our case. And in our case, we have to do this crisscross applesauce shit. And I'll do it over here on the side because I'm running out of space. We'll make a new speed. For B1, our terms are going to be 3 multiplied by 1 plus 0.1 kc minus 2 multiplied by 0 divided by 3, which ends up just being the same thing as 1 plus 0.1 kc. So go back to section 1, put that down here. 1 plus 0.1 kc. See, we solve for B1, we solve for B1. Same thing for B2. Let's solve for B2. B2 is equal to 3 multiplied by 0, because remember, we're doing the big crisscross. 3 multiplied by 0, 2 multiplied by 0, minus 2 multiplied by 0, divided by 3, which is equal to 0, because 0 divided by anything is 0. Real quick, for B1, I just want to show you. 3 multiplied by this here, 2 multiplied by this, boom. So you know B0, B2 0, and then B3 is immediately 0. How about C1? So C1 would be down here just for practice. 1 plus 0.1 kc multiplied by 0. Minus 3 multiplied by 0. Divided by 1 plus 0.1 kc equals 0. And essentially, if you know C1 is 0, then you know C2 and C3 have to be 0, etc. Cool. Now we filled a Routh array, which I shall highlight in this color, in this nasty yellow that you can barely see. So remember, in order to say the system is stable, one, we already solved. The characteristic equation needs all positive coefficients, which we have kc greater than 10. So the Routh array also needs all positive coefficients. In this case, life is simple. We also have k1 0.1 kc needs to be greater than 0. Solve for it. It also turns out that the Routh array needs to be, kc needs to be greater than negative 10 in order to be stable. So our answer officially is going to be the controller is stable as long as kc is greater than negative 10. And that's it. That's your answer. Now I want to say something. This is not always true. What happened here and here matching is not always true. Sometimes you'll get a range and that your Ruth array, let's say it would have been negative 20. Your answer to keep this positive and the Ruth array would have been negative 20. Your answer changes a little bit. Instead of being only greater than negative 10, it would be negative 20 in between KC in between negative 10. So that's a possible answer too, if your Ruth array gives you a different answer. So it just depends on how the math works out. In this case, life is easy. I think they do this on purpose so you don't have to go balls to the wall like I just did, but I like going to be thorough. So as long as KC is greater than negative 10, it should be good. I'm going to go back to the question. So a system is not stable. And as we just saw, KC is not between two integers. And I just want to say their answer is A, but I'll go back to the 89 answer key and I want to show you something that makes no sense. Because they didn't do this correctly. So they set up everything like we set up. They solved the characteristic equation exactly how we set up. Look at the Ruth array, guys. Why the fuck do they only have 1 plus KC? What happened to 0.1? You see? Like their answer hinges on this. Their Ruth array is just wrong. So their whole answer is wrong. Whoever made this package screwed up. Like if you're in the exam and you go through all that work, you might be afraid. We did it correctly. It should be KC greater than negative 10 in order to work. But there you go. That's the official way of doing that. So I know it's A, and I know the packet doesn't get the answer key does it wrong, but there's the full way of doing it. Okay, 10 more questions. It's almost been 2 hours. I'm gonna finish. Okay, number 90. Control strategy below is a good example of blank. It's a feedback controller, feed forward and feedback, just the feedback or just the damping. Okay. So, I mean, if you're in the middle of an exam, you don't have access to Google, but that's why you're watching this video, right? For someone to explain it to you. And of course, I don't have it here. Give me 1 second, boys and girls. I don't need that anymore. And you guys are going to see me struggle opening my notes, which this is what I'm reading off, which you cheated. Here. Okay. Here's a feed forward controller example. Feedback control scheme. I want you guys to realize something. In a feedback control scheme, the exit fluid or the exit temperature, the exit whatever of your system is telling the controller to open the valve to get more heat. A feedback controller requires you to be at the exit or be at the fluid or something, not in the beginning, be telling your system to feed it more energy or to feed it more processed fluid, to feed it whatever, to keep it warm, hot, cold, whatever. Whereas a feed forward controller is kind of as it sounds. You need the system and the inlet to tell the system to keep it warm, etc., which you can see here. Now I'm going to clear my screen and I'm going to scroll up because I have it here highlighted. Okay. So your feed forward in this picture is shown here in blue, where the blue feed forward controls the flow of the steam before the exit. It controls how much steam is entering based on the flow of the cold fluid entering the process. Basically, we follow this cold fluid process. It goes through this flow transmitter, which goes into this controller, which then goes to this summing controller. It goes back to this steam, which is telling the whole bath to maintain a certain temperature based on how fast this cold process fluid is coming in. That is an example of feed forward. Now, whereas this in red, the red is a feedback temperature because you'll see that here's the exit hot fluid. This is measuring the exit hot fluid temperature, which is just a tank. And it'll tell the temperature transmitter to tell the feedback controller, to tell the summing controller, to tell the steam controller to pump more steam based on the temperature of your exit process steam. That sounds really complicated, but all it's doing is this at the same time. Now, you might be asking, what is damping controller? Well, to put simply, and since I have the time to do this, I want you to Google damping controller at home. In fact, I'll do it with you right now. if you do a damping controller, I want you to notice that you get no pictures. So I guarantee it means something. But in the sake of this, if I don't see it on Google that quickly, it tells me that it's just a red herring of an answer. I wouldn't worry about too much. So it obviously isn't in this picture. So the answer is B, feed forward and feedback control. So that's 90. Okay. 91. So these are the last 91, 92 are the last big boy questions that I can work through. The rest are just going to be verbal, which thank God because my voice kind of hurts. Actually, 93 is also verbal. Yeah, the rest aren't that hard. So we're gonna go through 91 and 90, 91 to 93. These are last like real big boys. Okay. We're gonna screenshot 91 because it's gonna be another OneNote. And let's delete. And let's get to work. I don't know why I want it. No, I don't want to export. What the fuck is it doing? Please excuse me, I don't have an editor. Please don't be mad, guys. Okay. Okay. Ben, let's get this party started. I want to go through two things real quick before we do this. One, when you see two blocks in series in a process control diagrams like this, so let's say this is G of P, this is G of V. These two blocks, and this is Y, SP, and this is Y, no, this is YSP, and this is just Y. You would describe the system pretty simply. You multiply, it would be G of P, G of V, Y, equal, excuse me, let me, it'd be G of V, G of P, GY of SP equals Y. When you see them in series like this, you just multiply G of P to combine them. Pretty simple. Now, let's say you see this type of block here. This is a plus, this is a plus. Here's a R. Here's a block, G of V. Here's your exit, Y. The reason I show it like this is because remember, Y at the exit will also be Y here and Y here, assuming there's no blocks in the middle. So how would you combine these two here? Well, that's simple. That's just G of V times Y. Now, how do I combine them here at this adding block? Well, that's simple. You rewrite the whole thing, and then you realize you have G of V, Y, R, Y. Now you combine them at the adding block by literally doing what this block is telling you, which is adding them. Just R plus G of V of Y. Rewrite the whole thing, and your exit is Y. And that's it. The adding block tells you to add, and then when they're in series, you multiply. I think that's very important to get out of the way. Those are the basic rules of this. They're about to get here. I don't want this in my face. They're not that hard. What the fuck is it doing? So let me erase these. I don't know why it doesn't want to let me. And let's get the party started. So first things first. I believe the easiest route here, I'm going to rewrite C of S as D of S just because my handwriting is trash and it gets confusing. As stated before, C of S would be here, C of S would be here. And I want to get rid of this feedback control loop immediately. So the first thing I'm going to do is follow what this circle is telling me. It says R is plus, and in the bottom feedback is negative. It is literally just telling you to subtract R from C. Again, remember, folks, I'm going to rewrite C of S as D of S because I cannot, for the life of me, write a C that looks not disgusting. And in that case, we're going to take this D of S and this R of S and do what this block is telling us, which is subtract each other. So we're going to do R of S minus D of S which are going into KC, which are going into G of S, which is coming out as C of S, or in this case, D of S to keep things consistent. As stated before, how do we combine everything? Well, that's actually not too hard. We combine anything since they're all in series with the multiplication. Remember, this is the input, this is the output. So it's simple. We do R of S minus D of S, all being multiplied by KC G of S equal to the output D of S. We're not done though, guys, because it is physically asking us for the transfer function D of S divided by R of S. How do we do that? We need to simplify this in order to get there. To make life simple, what you should do is now distribute what's on the outside of your distribute what is on the outside to the parentheses. So R of S multiplied by G of S multiplied by KC subtracted by D of S multiplied by G of S multiplied by KC is equal to D of S. Here at this point, you want to combine like terms with each other. So we get R of S, G of S, KC is equal to D of S minus D of S, G of S, KC. Now, the reason this is important is because remember, our goal here is to get D of S divided by R of S. So we need to get this D of S by itself. So remember, you can do factor the D of S out. 1 minus G of S, KC, R of S, G of S, KC. Get what they want, D of S divided by R of S. So that's going to become D of S divided by R of S, just by dividing R of S to the other side. G of S, KC divided by 1 minus G of S, KC. Now remember, we're not done here. This is what you'd be done if they didn't have any numbers to fill in. But sadly, our G of S has this actual transfer function worth. So let's substitute it. We're going to get 3 divided by 8S plus 1 multiplied by KC divided by 1 minus 3 over 8S plus 1 multiplied by KC. And in a similar fashion as we did before, we need to make sure 1 can be subtracted. We need to excuse me, really quick. I made a minor mistake. Notice how it's negative D of S, G of S, K of S. We moved it to the other side, so this is positive, and this is also positive. And this would be positive too. Excuse me, I misspoke. Or I didn't catch that. I'm sorry. Remember, this is being moved to the other side over here. So you add it to the other side, not subtract it again. So as I was saying, this denominator here, we have to combine like terms, which I'm going to just skip the steps. You guys know how to combine factors here at this point. So it'd be 3KC divided by 8S plus 1 divided by 8S plus 1 divided by 8S plus 1. Because remember, in order to combine these, they have to have the same denominator, plus 3KC divided by 8S plus 1. Which is nice because you get 3KC divided by 8S plus 1 divided by 8S plus 1 plus 3KC, all divided by 8S plus 1. Now, here's the cool part, guys. Watch this. The denominators cancel. And you're going to be left with 3KC divided by 8S plus 1 plus 3KC as your transfer function D of S over R of S. All that math. Jesus Christ, we got there. which gets you the answer D as in dog. You see how they trick you up here? They give you that -1 over here in case you fucked up. Okay. Now it gets a little bit more rough here with 92, but it's not that bad. 92 is just more annoying. So we're gonna do the same thing, and we're gonna screenshot it, and we'll just go for it. Same idea. They want C divided by R, but as you guys know, I'm gonna make it D again because my handwriting is too bad for deciphering it. Okay, same idea. We're gonna start destroying this sucker 1 inch at a time. We want to combine as much as we can immediately. So I'm gonna write here, immediately tell you, remember, this is C, this is C. This B, fuck that B, it just confuses you. This M, fuck that M. This L you gotta keep though. The reason I raise B and M is because normally they'll be like M equals G1, C1 multiplied by whatever the hell it comes out. I just think it makes it more confusing substituting stuff. I'm a guy who just like seeing raw math. We're gonna go the raw math route. So in the same essence as last time, we're gonna combine this feedback loop immediately. And the first thing I want you guys to notice, I'm going to simplify this immediately. I'm going to redraw it. It's going to be R going into plus minus circle. Here on the bottom, I'm going to make my life easy, and I'm immediately can combine block H with C, which it'll just be H. And remember, we're replacing C with D of S. H multiplied by D of S. And that's your feedback loop to GC to G1 to the add block 1L to G2, which would then connect it down here. Ignore this line to D. A little messy, but I immediately connected H and C from the bottom. With that said, I'm now going to connect R and DR with this add block. But again, remember, this here is a subtraction. So you're going to combine them the same way we did before. So it's going to be R of S. I'm just going to put an S because it makes it easier to decipher. Minus D of S multiplied by H in parentheses. All combined now, where you're going to get the G of C, the G of 1, the add block, which is plus with L, and G of C to D of S. This D of S stays though. All we did was erase this. All we did now was erase this part and combine the here. Now with this said, remember our other loop. We're going to end up here. Now how we end up here is simple. Multiply everything together because we have them all in series. So from left to right, R of S minus D of S times H multiplied by G of C, G of 1, all next to this add block, a plus to L, coming out of G of C, which comes out to D of S. Okay, combine them with the add block. In the same sense, the difference here, up here we had a subtract block, here we have an add block. Add them together, R of S minus D of S times H multiplied by G of C, G of 1, plus L. Now we combine this whole add block together. We have a new arrow into G of C into D of S. Now we have a simple chain in series where we can multiply everything. And remember, this is your output. So then it's going to be R of S minus D of S times H, all in parentheses, multiply C, G of C, G of 1 plus L, all being multiplied by. And to make things clearer, this is a 2. I just made it look ugly. That's a 2. That's a 2. This is a 2. All multiplied by that disgusting G of 2 equal to the output, which is D of S. Now your hell is almost over, friends. We need to simplify everything. So simplify everything on the inside and work your way on the outside for these parentheses. Distribute this into this into this. So it'll be R of S, G of C, G of 1 minus D of S, H, G of C, G of 1 plus L, all in parentheses with G2 equals D of S. Finish your distributing here, here to here to here. So it's R of S, G of C, G of 1, G2 minus D of S, H, GC, G1, G2 plus L of G2 equals D of S. Remember, as before, combine like terms, because what we're trying to do is D divided by R. So R of S, G of C, G of 1, G of 2 equals to D of S. It becomes plus because you're adding it to the other side, D of S, G, don't forget the H, G of C, G of 1, G of 2. Remember, same idea as last time. Get that D by itself, so factor it out. D of S, 1 plus H, G, C, G1, G2. Don't forget this. I dropped on the top. I dropped by accident LG2. So there you go. Don't forget the LG2. But the right side is fine. So R of S, G of C, G of 1, G of 2 plus LG2 equals to that. Now, I want to quickly talk about this L term right here. And the reason I want to talk about this L term is that it's the same thing as R and the same thing as D. It's a variable in your transfer control block that you'll never be able to get by itself. It's not a transfer function. It is a variable. So it's kind of the same thing as D of S or D divided by R. You could also do R divided by L. And we'll get to that in a second. It'll make more sense when you see it this way. So now that we have D of S by itself, we can now rewrite this whole term as D of S is equal to dividing all of this out. So it'll be R of S, R of S, GC, G1, G2 divided by 1 plus H, GC, G1, G2. I am sorry, this looks so ugly. Plus LG2 divided by 1 plus H, GC, G1, G2. Now, going back to what I was saying before, the reason you can write this two ways is that in the magical world of transfer functions, you can cover up the side that's R of S, or you can cover up the side that has the L. And what I mean by cover up is like pretend it doesn't exist. So like legitimately cross it out and then say, what is the transfer function? So you have two transfer functions. In this case, you could have D of S divided by R of S, or D of S divided by L of S. I should have been writing it as S, but L. In this case, we'll keep it consistent with our terms. It'll be L. So in that case, D of S over R of S, so D over R is equal to GC, G1, G2 divided by 1 plus H, GC, G1, G2. And that's just coming from covering up and pretending this doesn't exist and then getting R of S by D of S divided by R of S. So just moving this down here. Assuming that other side doesn't exist. How about D divided by L? That's pretending this doesn't exist and then getting D divided by L. So that would be equal to G2 divided by 1 plus H plus GC, or times GC times G1 times G2. So these are the two transfer functions that could potentially exist in this control variable. Now, going back to the answer key, which was super long-winded, you can clearly see that the only one of those that exists that we did was A. It doesn't show you both of them, but it's A. This question could, in theory, say what two transfer functions can exist, but it only asks for one. So it's a red herring. You have to go through all that work because you don't know just off the top of your head. So it'd have to be A based on all that work. 93. 93 says long-term exposure to loud noise is known to cause hearing loss. OSHA has limits on the number of hours at the specific noise level for noise environments below. What is ambient noise protection required? So if you go to the FE handbook and you go under OSHA, they actually provide permissible noise limits. They give you an equation, and they give you an equation right here, which says noise D should not exceed 100%. So it'll be D equals 100 times the summation of CI divided by TI, where CI is the time spent at that specific noise level, where TI is the time permitted at that noise level. So in that case, CI in our case, if you go back to our here, CI would be 16, 4, or 1. TI would be 32 at 80, 16 at 85, 8 at 94 at 95. So in our case, we'll take the numbers from this table, the TI numbers, which are all from this table. The CI numbers were from the question, and 100 is just a constant. So in this case, it'll be D is equal to 100 multiplied by the summation, which in this case would be at 80 is CI, time spent in there according to the question, 16. TI, according to the question, according to the table I just showed you, says the limited number of time in there you can spend is 32 hours, plus the next one, which is 90, which would be 4 based on the question, which is here, divided by TI, which is in the table I showed you, which has a number of 8. Go back in the video and look at it. And 100, you get 1. And at the table I showed you, it says 2. You crunch the math, and you're going to get a number of 150 here. Luckily for you, I'm going back to the table anyways. So you see, we get this 32 from right here. We get this 8 from right here. We get this 2 from right here. Those are your TIs, and then the 16, 4, and 1 are from the 80, 90, and 100 decibel levels from the question. 100 is a constant. You add that, you get 150. So do you need ambient noise? If D is greater than 100, noise ambient is required. So there's your answer. Sir? Clear, clear. Sorry about that, guys. I am a little out of practice. So the answer is C. Yes, ambient noise is required. 94. Safety data sheets, SDS, provide which information about chemicals is essential for conducting hazard analysis, which can be obtained from an SDS. Select all that applies. So this is something that if you don't work yet, you'll eventually just know. So it does tell you which chemical is flammable. The recommendations of, yes, it also tells you the recommendation fire extinguishers. It tells you the exposure limits because you don't want to die. It tells you the recommended material construction so you don't accidentally kill yourself. It tells you the physical properties. It does not, and I repeat, does not give you the reactions for producing the chemical. You are not given the plans to make this shit, so no, it does not. Recommendation for PPE with a chemical, PPE, personal protective equipment, of course. Those are just those are free points, but they expect you to be so burnt out from the last like 5 questions that you can't answer that. Okay. Whoa. 95. A chemical tank is steam cleaned with superheated steam, and immediately after steaming, the tank is sealed and left to cool overnight. Significant consequences would most likely be. Okay, can steam be corrosive to contaminants that damage the tank? I mean, it could be, but it's not the most significant consequence. It won't kill anybody. And likely, if you're running steam through your tank, you probably already thought about being it's okay. So leaving it in there for that reason will not work. The tank will not cool as fast if we're vented. That's probably true, but I mean, if you were cleaning with superheated steam, I think you're not going to be using it for a while. Most of the time, if you're maintaining equipment, it'll be off and you're not planning to use it for a while, at least at the pilot scale I work at. Maximum design temperature would be exceeded. Again, you should know that, and why would you be running superheated steam through it? Unless you know that's for sure. So those are immediate out of the question. So the only answer is B, reduce pressure in the tank could cause the tank to collapse. But I also want to give it to you in a perspective that makes a little bit more chemistry sense, because I'm a chemist after all, and a chemical engineer. I have 2 degrees. I want to think about a vessel. Think of the combined gas law, P1 V1 over P T2 or T1 equal to P1 V1 divided by T1. Ideally, a storage tank is going to have constant volume, so those are kicked out. So if you have a pressure and a temperature that are really high, let's say you have a pressure of let's just say you have 1 ATM at a pressure of, I don't know, 500 Kelvin for your P1 and your V1. Assuming temperature drops to something, I don't know, let's say 273 Kelvin, and you're already at atmospheric pressure, well, based on this correlation, P1 divided by T1, if temperature goes down, pressure goes down. If pressure goes down, temperature goes down. Ideally, that's how a rice cooker works, right? If you have higher pressure, the higher the temperature can go. So if we lower the temperature from that superheated steam state, and you're already at atmospheric pressure, what could happen is that your atmospheric pressure goes to negative, which is idea of a vacuum. So let's just say negative 0.5 ATM. These are just numbers I'm making out of my ass. And if you go into a vacuum state and it's a storage tank, which I assume is meant to hold a lot of big chemicals, you could potentially kill yourself by having the thing implode on itself. And that's just using some basic chemistry. That's why B would be the right answer. Again, people like to talk shit, but most chemical engineers don't know shit about chemistry, and that's one of the good examples. 96. Total of 50 grams of dry cleaning fluid per chloride ethylene is spilled and allowed to evaporate in a 4x4x4 room, dispersing completely. The safety site officer would probably do all of those. Okay, so you can actually find in the safety section of the chemical engineering handbook, where is it? Exposure limits of selected compound workplace. Here it tells you allowable workplace exposure levels, which are milligrams per meter cubed of perchlorate ethylene, which is right here. In our case, the question, or our limit here is 188 milligram per meter cube. And that's pretty easy to get. Like, these are free points here at the end. They're just literally just shooting them at you because they think you're destroyed mentally, which, I mean, I am. So first things first, it'd be 50 grams multiplied by, for every 1,000 milligrams is 1 gram, divided by 4 times 4 times 4, which would make it meter cubed. This is milligrams. This ends up giving you 781 point whatever, 781.25 milligrams per meter cubed. Clearly 781, and our exposure limit here of 188 for perchlorate milligram per meter cubed. 781 is pretty fucking big. An idea that I think you probably would be dead with about 7 times the amount of allowable to be working. So and this guy should probably make a wise decision. So let's go back to the question and what are the answers could be. So here. So what is the guy gonna do? Order the room to be evacuated and fully ventilated. Seems like a good idea. Allow people to continue work for brief periods. If it's over the exposure limit and you're letting people work there, you deserve to be fired. And honestly, you don't even deserve that past the PE. Allow work and continue while everyone is wearing appropriate breathing apparatus. That sounds something my old job would have done, but you should be sued if that happens because you can kill somebody. Allow work to continue while the room is being ventilated. That's a one drop from heaven. So obviously, the only answer is A. You don't want people working somewhere where it's just not safe. Okay, 97. Ignition hazard has been reduced for a vessel containing liquid or combustible vapor, potential concentration between LFL, which is lower flammable liquid levels, and upper flammable levels, lower flammable levels, upper flammable levels, expected. To most effectively reduce the ignition, you should. So let's think about it. Let's think about it. I think there's a graph. If not, I can just shoot. I had a graph. I don't have the graph on the cheat sheet. So how do you reduce ignition? Do you want to risk blowing your employees up by messing with the temperature, going 10% up or 10% up? Probably not. Do you want to risk blowing somebody up by increasing temperature or increasing pressure, then increase temperature? Probably not. Do you want to insulate the exterior vessel? I mean, what the hell is that going to be good for? I assume your vessels are already rated for explosion. They already been designed. You're not being the PE task to insulate this. It is designed for what you're putting in there. The only option would be the purge it with inert gas. And the reason I say this is because inert gas is inert because it's full octet. Remember, chemist. It doesn't want you to react. And if you have a lot of inert, then having so much inert will stop the combustion or explosion from happening. So it can't ignite. So there's no oxygen present. You lower the oxygen level, so there's no combustibility. And boom, there's no explosion. That's the best answer. So it'd be C. Okay, 98. 98 and 99, 98. It says violations of the rules of professional conduct should be reported to the local chapter of professional engineers, the state chapter of professional engineers, the office attorney in the country, board of registration. So here's nice. You go into the chemical engineering handbook. I actually do have the note for here. And it says it right here. In plain English, the violation and sanction provided in this section, the board shall have the power to sanction any to follow firms where a manager, advised officers, director, owners, managers found guilty of any conduct which would be considered violation. In other words, the board of registration has the right to take your credentials away, and it should be reported to them. So it's the board of registration in the state, which is D. As a professional engineer, originally licensed 30 years ago, you're asked to evaluate newly developed computerized control system for a public transportation system. You may accept this project if you're competent in the area of modern control systems, your professional engineer license is not elapsed. Again, if you have let that thing elapse, obviously you don't want to do it, but that's like no shit. So that's not the right answer. Your original area specialization was in transport systems, which you want a control system for a public transportation system. So why would they hire a guy whose original expertise was transport systems and not in control? I don't know. You have regular attended meetings of a professional engineering society, which means nothing. Meetings don't get you qualified. So the only two answers that are feasible are B or A. Now, the reason it's not B, well, it's because your license 30 years, I think you have to renew it every 5 years. So obviously you don't want to do that. The most competent answer is that you may accept this project. Obviously, you may accept it, not if your license has elapsed, so it can't be B, only if you're competent in modern control systems, which is what they're asking you to work in. The last one, thank God we're done. The United States has which of the following most directly affects public health and safety within electrical hazards? NCES rules of conduct, codes of ethic, Electrical Institute of Electronic Engineers. Those guys tell you about electronics and those guys tell you about papers. No. Codes of Ethics of Society of Professional Engineers, they don't do anything about this. The only two answers that are plausible are NCES, which I'm not sure what they are, and the National Electrical Code of the Fire Protection Association. Remember, if you're on an exam, you need to guess. Just guess the National Fire Association because they do everything. In this case, the National Electrical Code from them is actually true, and that's a thing you can Google. Again, if you need to look at it, it's in the book, but it just you have to read through it, and it's something you sort of just have to know. I can't really teach you, so the answer is D. And then with that, I have done it. I hope you guys enjoyed this series, this video that's been 6 months late. I do apologize. I've been going through it. Motivation was low. But after this last 2.5 hour and a half, 2 hours, I don't know how long this is. I'll see once it's done in post-production. I hope you guys learned to be better engineers. And if you pass the FE exam, let me know. I might say I'll take it. I still haven't decided. I'm smart for it, but I'm kind of lazy too. in case you guys haven't noticed. Anyways, thank you for watching. As remember, if you need anything else, just put it in the comments, and if I went through something wrong, correct me. And that's all I got to say. Thank you.